All right. We're going to start off with a verbal drill, and then we're going to take a break, and then we're going to do some math, some number properties, and some data interpretation. Stacy's going to take us through our verbal drill, and then I'll take over after our break and run us through math. So let's get going. It's actually a pretty packed class, and we're going to do our best to get us done on time. Okay, here you go, Stacy. Here's the mic.
Hey guys, how's everybody doing tonight? Give me a smiley face if I'm coming through loud and clear, if you can hear me. Oh, it looks like Hannah's lagging a little bit with her connection, but everybody else should hear me. All right, so we're going to do a mixed drill on verbal. We're going to do a bunch of different questions, fast and furious. We're going to do some, it's actually called the hardcore verbal drill. We're going to do some hard words, some hard stuff tonight, and see how we do with it. So without further ado, try this one. Just give me a green check mark when you're done, and then I will ask you to tell me in the chat window what answers you got. All right, we've got green checks from almost everybody. So let's go ahead and take a look at this one. So I've changed the chat so that you guys can only send to the moderators. So go ahead and tell me in the chat. I put letters next to the answers here. Go ahead and tell me what letters you picked. All right, so let's see what we've got here. Some agreement, some disagreement. I've got a couple of votes for B as in boy. I've got a vote for C, a vote for E, and a couple of votes for F. Anybody else want to weigh in? Only 3 people so far have told me what they got. We have another vote for C. Okay, so everything that has gotten a vote so far has gotten 2 votes. Oh, except for E. So you guys agree that you don't like answer choice A, nobody picked that. And you don't like answer choice D, nobody picked that. So let me start by just asking you guys, does anybody know, if you can, tell me the definition for either A or D? Tell me the letter that you're giving me, and tell me the definition for it, just so that we can know whether we were actually right to eliminate those 2. A or D, tell me the letter, and then tell me what your definition is for it. So I've got, for A, I've got petty or quibbling. Yes, and the way that this word, these words, by the way, that we have in the answer choices here, what part of speech are they? Do we have nouns? Do we have verbs? Do we have adjectives? What are we dealing with here? Anybody know? You can look in the sentence, too, to see how they'd be used. Yeah, good, Meredith. We've got nouns. Oh, and Lauren's got it, too. We've got nouns. Okay, so we've got nouns here. So pettifoggers, they're petty and quibbling. They're people who are petty and quibbling, because we're dealing with nouns here, basically. So you've got people who are quibbling over trifles or something like that. Is that what we want in the blank? How do we know? So how do we know what we want in the blank in this one? You guys tell me. What were your clues on this one? You can grab the highlighter, the yellow marker over here, and highlight for me what you thought the clues were, or you can type in the chat window, whatever you prefer. We've got an or, and then insincere flatterers. Nice. Do others agree, disagree? Anything else you want to add? Do you think there's anything else in here that tells us what should go here? Self-respect, I like that one too, among the subordinates. Now tell me, for the words that we've highlighted so far and the things that we're talking about, are these same direction or different direction? So are we looking for something that goes along with these, or are we looking for something that's different or opposite direction from these? I've got one vote for same. I've got another vote go for along, goes along. Okay, so I've got 2 votes for the same, and yeah, you guys are right. So we're looking for something here in this blank that's going to go along with what's going on here. I want you to have self-respect. I don't want you, I'm your boss, I don't want you to be insincere flatterers or something that's very similar to insincere flatterers or something along those lines. Okay, good. So pettifoggers, we said that was somebody being petty or quibbling or something like that. All right, so that's not what we're looking for. It's not having to do with insincere flattery, so we can get rid of that one. And then I also had, let's see, myrmidons. Okay, so I've got myrmidons are warriors. Myrmidons are warriors, that is true. They're also they're a specific kind of warrior. They have a specific characteristic. They're not the leaders. They're the people who follow unquestioningly whatever the leader says and just they do whatever, you know, Caesar says or whoever it is that's telling them what to do. Whoever the you know, the leader or the chief is. So that's what a myrmidon is. Someone's telling me, okay, with that word I think of the movie Troy. Yeah, I like that. Yeah, definitely what's going on in Troy. So the myrmidons are the people who, they're basically the rank and file. They are warriors, but they're the rank and file who are just doing whatever you, the boss, say without actually thinking for themselves. Does that go along with it all what we're talking about here or not? What do you guys think? Adam's saying, well, the boss wouldn't want myrmidons because she wants someone with self-respect who won't just do what she says without asking. So that makes it a possible answer. And I agree with that. I think we should leave it in for now while we look at everything else. It's possible. We'll see. Okay, so we've got B, C, E, and F, all of which did actually get votes too, so we got to go figure out what our definitions there are. So go ahead and tell me, again, tell me the letter that you're telling me, but for B, C, E, and F, tell me what you think the definition is, and then we'll use that to see whether it fits the clues that we've got up here. So anyone you want, just tell me the letter, and then tell me your definition. For B, charlatans, I think that means fakers. You are exactly right. It means fakers, frauds, something like that. So certainly as a boss, I wouldn't want fakers or frauds working for me. That's definitely the case. Is that the meaning of the words that they're talking about here? I don't want anybody bad working for me who's bad in any way. But is that the specific, what characteristic that the boss up here is talking about? Yes or no? What do you think? This one's a little tricky, right? We have to distinguish between this question in general. We have to distinguish between negative traits, because clearly the boss doesn't want anybody working for her who has a negative trait. So we have to distinguish between that and the specific negative trait that she's trying to get at right here. So what do we think about this one? So I've got a vote for no. It doesn't pertain to self-respect. It pertains to faking stuff. And I've got another one with, well, yeah, but it doesn't really go along with insincere flattery. Okay, so this one, and now we're starting to make judgment calls between different things, right? So we've got this one, which is more about faking or fraud. And then we've got this one, which means following orders without thinking for yourself. And so we'd have to ask ourselves, okay, between these, which one is closer to what's going on here? And of course, we're allowed to select 2 answers, so maybe they're both close. What about toadies or shysters or confabulators? What do you guys think about these other ones? I agree. I think, sorry, that was a teacher telling me. Myrmidon is the hardest word. I agree. Someone's telling me like the Toadies Kid Music. I didn't know that was actually the name of a band. Can you use that to help you remember what the definition of toadies is? I'll figure out a way. All right, so we've got E. We've got liars for E. Yeah, so E's got a couple of definitions. E can just mean, confabulators can just be who are chatters, I'll call it, or people who are, there's a really good French word for this called bavarder. It's just, chattering away, talking away. But it can also mean making stuff up, basically, so lying. And making stuff up to finish up a story or add to a story or something like that, so lying. Okay. So that's interesting. These two, the charlatans and the confabulators, kind of seem to go together. They both have to do with faking or making stuff up or something like that. This one is different than the other two. Now, remember when we've talked about these before, one of the things that we've talked about is that because they want us to select two answer choices, we'll often have two sets of pairs. One pair will be the right answer, and one pair will be, there'll be a pair, but they won't be going with whatever's going on in the problem. And then you may have a third pair, or the other two answers may not be pairs at all. They may not go together. So we've now got a pair between B and F. Interesting to think about if we have to make a guess later. We definitely either want to guess both of these or neither of these. What about toadies and shysters? Give me nobody's typing now. Give me a frowny face if you're not sure enough of what toadies and shysters mean to give me a definition. And if you can't actually give me a definition, just start typing and give it to me. All right, no typing, and I'm getting a frowny anyway. I'm getting some frownies. All right, so toadies are basically people who flatter somebody just to try to get something out of them or to like suck up to them. So toadies are kind of like suck-ups. Another GRE type word that's a synonym for toadies is something called a sycophant. I'm going to type that in the chat window. Sycophant. So this is somebody who's sucking up to somebody else, just doing whatever you say, or flattering you, just to try to get you to, do something good for them or something like that. And then shyster is basically somebody who's unscrupulous professionally. It's specifically talking about professionally, which is good. Oh, did you, Liz? Cool. But basically somebody who would be willing to do something illegal or maybe kind of borderline illegal or stab a colleague in the back or something like that. So now that we've got the easier definitions up here, given this, what do you guys think? Tell me what you think are the two that should go in this blank right here based on the clues that you pointed out to me. Did you keep your answer the same, or are you changing it? Oops, and I just noticed I didn't put pettifoggers up there. I'm going to put it up there. So what do you guys think? You're going to go with your original two answers, or are you going to change anything? Got some changes coming in. Everybody likes C now. So everybody's agreeing that C is a good one, and I agree too. C is really the best one for this blank, that toadies and sucking up. And then I've got I've got more votes for D than for E, but I've got some D's and some E's in there. In this case, D is the other answer. It's not quite as tight or quite as close as the toadies thing, but it's really in terms of doing something without kind of having your own point of view or your own will or making decisions for yourself or something like that. And that's what she's getting at here, where she wants self-respect among the subordinates. And then the insincere flatterers kind of goes to the sucking up piece of it right there. The unscrupulous professionally is more about you're willing to do like illegal things, basically, or borderline illegal things, or even just immoral things in order to get the job done or something like that, which is certainly, again, you wouldn't want that kind of person working for you. Well, I guess it depends on what you do, what you want your employees to be able to do. But let's hope that you don't want somebody like that working for you, but it's not exactly what we're getting at with the clues that are up here. And again, note that B and F were our pair. They were paired. They were just the wrong pair. That's all, the wrong definition. All right, any questions on this one? Give me a smiley face if you're good with the things that we talked about on this one. Give me a frowny face if there's anything you want to talk about, or of course just start typing or raise your hand if there's anything you want to talk about. And I just want to talk about our process here. So we read the sentence, just as a summary, we read the sentence, we're going and looking for our clues to try to tell us what's going in the blank. We also need to decide whether our clues are in the same direction or the opposite direction from the blank. And then we're looking for something that will basically just go in the blank, and we can reuse. Remember, we can reuse words. So one possibility is to stick that in the blank, or I don't want people with no self-respect or something like that in the blank. So I can just reuse the words kind of and put them in there. It's because we're looking for two answer choices, they may not be exactly, or one may not be exactly the perfect word. I would say on this one that toadies is really the perfect word. And myrmidons is, it's an okay word, but it's not as great as toadies for fitting this exact situation. But you'll often see that when you have to pick two answers, that the second one will be a little bit looser, but it still will be tied into something that's going on, some clue that's going on in the sentence. Okay, let's go ahead and take a look at our next one. Try this one. Same drill. Give me a green check mark when you're done. I'm going to put some letters up, and then when you're done, I'm going to have you tell me what letters you picked. And don't forget to give me that green check when you're done. I'm getting answers in without the green checks. Thank you. All right, what do we got going on this one? Let me scroll back up. All right, some answers changing. I vote for BC. No, wait, I want to make it BD. Somebody else also thought BD, BF, BD, C. Another F. All right, so lots of people like B. And then we've got some C's and D's. Oh, no, sorry, the C was changed. We've got some D's and E's and F's in there. All right, interesting. All right, so pick any word you want. Any word you want. Tell me the letter and tell me the definition. Any word you want. Tell me the letter and the definition. All right, I'm being told vaunt is brag or boastful, something like that. Yeah, to brag or to be boastful. Good, good. D is to disregard. You might have heard the phrase flout the rules. You guys heard that? So flouting the rules, kind of disregarding, being contemptuous of, yeah, whatever. I don't need to study for this test. Whatever. All right, let's see. For C, I've got announce with a question mark. Yes, it does have something to do with trying to communicate something or announce something to people. Intimate, so it's not intimate, first of all, which is a different word. It's the more common word, a more common usage of the word. This is intimate, and it's to communicate something delicately, or to imply something or something like that, rather than to just come out and sort of baldly state it. Good, good. For E, we've got to obtain or get from somebody something, to obtain, to draw out, to get something out, something like that. Good. I'm just going back up to see if I missed any of these. I don't think I saw any yet for A or B, by the way. All right, nobody wants to tell me what A and B mean? I see a couple people typing. I'll give you a chance. Okay, so for tout, we've got a couple people telling me brag. Yep, to brag, but not in, tout is usually more of a positive connotation, where vaunt is a little bit more of a negative connotation of kind of the same idea. So tout is more to talk something up. I'm going to tout this great new GRE class that I took, right? Which you're all going to do. You've all already been doing that, right? So to talk something up, to tout it. And to fetter, yes. Chains, to chain or shackle, yeah. So to fetter is to shackle or to restrain or something like that. Oops, not restrain, but restrain. There we go. Okay, so a bunch of things here. All right. What are our clues for this one? Highlighter, grab that yellow highlighter. What tells you what we're looking for? So we've got braggadocio. And that braggadocio, what about it? The braggadocio just exists. I would argue there's something else important there that we actually need to highlight as part of the clue. I like the whereas, I like the appropriate to, vocally something, I like all of that. Yeah, but never acceptable. So I'm saying one thing is, on the one hand, in some places, bragging is never okay, period. Whereas, oh, what's whereas mean? Same direction, different direction? Totally different direction. Okay. So yeah, different direction. Whereas, okay, so bragging is never good sometimes in some places, in some cultures. Whereas, change of direction. Sometimes it's appropriate. It's okay in other places to what? So what are we looking for to go here? What kind of word or what kind of meaning are we looking for there? To brag. Yes, exactly. So bragging. So it's never acceptable in some cultures, and other places or other cultures it is appropriate to do that sometimes. Okay. So now going down and taking a look at our answers, we're looking for something that goes along with that idea of bragging. Fettering and shackling and restraining, nothing about bragging there. To talk something up, maybe that goes along the same lines as bragging. Okay. Intimate, to communicate delicately or imply. Well, it's talking about communicating something, certainly. Maybe we'll leave that in for now. Flout is to disregard the rules. I'm going to flout my accomplishments. Wait, I'm going to disregard my accomplishments? No, that's not what I want. Okay. Be really careful with this word. I had a number of people pick this word. Were you guys possibly getting flout mixed up with the word flaunt? Especially with the word vaunt in there as well? Is that possible? What's flaunt? What does it mean to flaunt something? To show off? Hey, to brag even. If the word flaunt had been here, that would have been a good one to pick. Close, but different word, different meaning. So that one's not what we want there. To elicit, to obtain or draw out. This one could potentially be tempting, I can see, because you're talking about eliciting somebody's accomplishments, but they're talking about doing this for yourself, your own accomplishments. So that one's not quite there. And then vaunt, hey, brag, that's what we said we wanted. Great. So we've got definitely one right there. That's good. And then between B and C, what do you guys think? Which one is closer to this concept that we want of bragging about yourself or bragging about your accomplishments? I've got one vote. Ed likes B, between B and C. And I've got another vote for B, yeah. So between B and C, talking something up is more talking yourself up, is more bragging than just, in fact, communicating delicately would not be bragging. It would sort of be the opposite of it. So we've got B there as well. The other potential I just want to point out to you, I had a couple of people, I think 2 or 3 people, picked the combination B and D. See any similarity there? So be careful about that too. It might have been just an unconscious thing where you saw tout and you knew that one was good and you liked it, and then you saw flout and you just kind of went with it. But it's not actually the same meaning there. Maybe even the flout, flaunt, vaunt thing got you. Okay, any questions on this one? Any questions? Give me a hand clap if you don't have any questions. We're going to mix it up so I can make sure you're paying attention. And start typing, raise your hand, let me know, give me a frowny face if you have any questions about this one. All right, cool. Are you ready for another one then? Here you go. Oh, and you know the drill, green check mark when you're done, and then I'll ask you to put your answers in the chat window. All right, lots of green check marks. Go ahead and tell me what you actually, oh, I forgot to give you letters. Hang on a sec. We're going to do A, B, and C here. We're going to do X, Y, and Z over here. So go ahead and tell me your pair. All right, 2 votes in and you guys agree. 3 votes in and you guys agree. Interesting. All right, now we've got some disagreement. All right, our most popular choice for the first pair, our most popular choice is answer choice B, but we do have some C votes in there as well. And then for our second pair, most popular choice is X, but we do have some Y votes as well. I don't think we had any A's or any V's there. Oh no, I'm wrong. Sorry, we did have a Z vote as well. I don't think we had any A's though. Okay, so let's take the first pair, A, B, or C. Tell me a letter, give me a definition. A, B, or C. Actually, I'll open it up to all 6 of the words. Just go ahead and let's get them all up there. So any letter you want, all 6 of the words. And tell me the letter and tell me your definition. So for A, we've got developing or merging, nice. For growing, yep. For all those for A. B has to do with presumes something, right? Assumes, being presumptive is presuming something about somebody else or some situation or something like that. So let's see. And then we've got for Z, we've got to charm or to enchant. To enchant, and think of it as to deceive in particular. So to deceive somebody or to get something by deception or something like that. Yeah, tricked. That's another good one. X, annoyed or irritated. For piqued, good. Did I miss any? Just scrolling back up here. And what about charismatic and bowled over? I'm going to potentially date myself with this, but whenever I say the word charismatic, I think of a certain actress on Buffy the Vampire Slayer. Did anybody watch that? Am I the only one? If you know who I'm talking about, who am I talking about? Who's the actress? And I'm talking about, sorry, and I'm talking about the TV show, not the movie. So there was different people on the TV show and the movie. There is this actress in Buffy the Vampire Slayer. Her name is Charisma Carpenter. And she played like the bitchy Queen A mean girl type, basically. And so whenever I say the word charismatic, I immediately think of her Charisma. Her name on the show was not Charisma, that's her name in real life. So weird things like that, by the way, can sometimes help you to remember. Her name's Charisma Carpenter. She was like the mean girl type. And in real life, she was like an LA Laker cheerleader before she went into acting, and you can just imagine, you know. And charismatic means somebody who has a lot of personality and draws people to them, and you know, is very attractive, not even necessarily just in a physical way, although it can be physical, but it can just be a strong force of personality that gets people to want to be around them or listen to them or something like that. Okay, and then we've got bowled over, and bowled over is, I don't think anybody gave me a definition for this one, so this one's a little bit of an idiom. We've got two words here instead of just one, and it's a phrase. If you're not a native speaker, this is one of the things that's hard to pick up on. So to bowl somebody over is to impress in a really positive way, to really, I was bowled over by her charisma and how nice she was, or something like that, and to really be impressed in a positive way. Okay, now for first blank up here, we're going to do two things. So when you click on that highlighter, don't highlight yet, but click on that highlighter. When you click on it and look down here, you'll see that you can choose different colors. See that? So what I want you to do is for the first blank, I want you to highlight in yellow what you think helped you with the first blank. And for the second blank, I want you to go change your color to blue and then highlight what you thought the clues were for blue. For the second blank in blue. So we're going to do yellow for the first blank, and we're going to do blue for the second blank. And again, after you click on the highlighter thingy right here, that's when you can go down here and change your colors. All right, so for yellow, for our first blank, we're looking at some kind of approach is taught to novice, sometimes taught to novice or new salespeople. But change of direction, good. But, and we've got some yellow and blue here, and I agree that this one kind of helps us with both, good. Many customers are something by an overture, a fancy way of saying a hint of, or a, anything that smacks of a certain kind of characteristic or something like that. So many customers are, is this going to be positive or negative? Are they happy about hints of audacity and smugness? Or are they not super pleased about audacity and smugness from someone who's trying to sell them something? Yeah, definitely some negativeness going on there. All right. And for this one, I would say I have a pretty good clue for this second one. I want something negative. They're not happy about that. And this one I'm a little shakier on. And so I personally would want to start with the second one. Now, if you feel more comfortable with the first one, you start with the one that you're more comfortable with. But just remember, on these double blank ones, we're going to go with what we think we have the most clues for, what we think is easiest for ourselves, and that's a personal call. So I'm making the call on this one. We're going to start with the second blank because I feel more comfortable with that blank. I think I've got more clues there. Now, of these three that we've got, which one is the one that indicates unhappiness with? I am not happy with your audacity and smugness and trying to sell me this, I don't know, chia pet. What do you guys think? X, Y, or Z? And I like this. Someone's telling me, I didn't actually know what this one meant when I was doing it, but the other two didn't really work, so I picked that one. That's exactly what you want to do. Sometimes you get the right answer not by knowing the word, but by knowing that the other answers are wrong. And you guys are exactly right on this one. For our second blank, the correct word here is piqued. Okay, so customers are annoyed or irritated by audacity and smugness. Okay, good. What are we going to do with the first one? Well, now's where we would potentially, if you think you have enough clues, you can try to come up with something here. I personally struggled, actually, to come up with something that I thought would fit in the blank. I had to go and look down here and see what was going on. And someone's saying, okay, I thought piqued was positive, as in piqued my interest. Yes, you're right. Okay, so piqued can also mean basically like caught my attention. So the phrase piqued my interest, I'm just going to type this in here for you guys. Piqued my interest can mean something that caught my attention that made me go, that's interesting. Let's hear more about that. So yes, that's another usage of it. Just know that it can go both ways. So it also means the word pique also just means annoyed or irritated about something. So in that case, it actually works here too. So if you guys came up with something for this blank that you thought, okay, I can actually fill something in there before I go and look down here, then go ahead and tell me what that is in the chat window. If you couldn't, that's okay. Like I said, I didn't really have a strong idea of what I wanted to put here either. I did this one more, the second blank, or the first blank here more by coming and taking a look and thinking, does this make sense here or not? So it needs to be something, if we've gotten this far where we filled in this one, it needs to be something that could be potentially good, because otherwise why would you teach it to novice salespeople? So there's got to be something redeeming about it. But at the same time, it's dangerous because it could go negative. And it could make people think, no, you're too smug there. Ooh, I like it. Okay, so Lauren put a know-it-all approach. I really like that. Anybody else? Did anybody else have anything that you filled in for this one? So let's go with Lauren's know-it-all approach. So we can match that with developing. No, not really. A developing approach. A know-it-all approach would be someone who presumes things about the customer. Oh, yeah, maybe that could work. And then a charismatic approach. So I can imagine that it would be good for a salesperson to have a charismatic approach, because then people would want to listen to the salesperson and maybe buy what they tell you to buy, right? But does charismatic have within it the flip side that it can go negative because you can come across as audacious or smug? And someone's also telling me you can't really teach charisma. I agree, charisma is a difficult thing to teach. So this doesn't have the flip side where it flips over into, oh, but it could actually go wrong, and people could think you come across as too smug, and then it would turn them off, and they wouldn't want to buy anything from you. Where a know-it-all approach, that could be good. Oh, I trust you. I know what you're saying. Presuming approach where I know what you need or something like that. That could work, but it could also backfire, because someone could think, oh, you just think you know everything, and you think you know what I need, and you're wrong. And so that one is our correct answer. Presumptive is our correct answer for the first blank there. That one's a tough one, I think, that blank right there, that first blank. Any questions about that one? Any questions about this one? If you are ready, if you feel ready for the next question, go ahead and give me a smiley face. If you would like to discuss anything on this one, raise your hand or start typing. All right, we are going to hop out of vocab for a couple questions and do some RC. Here's your next one. For this one, I'm going to change the polling to A, B, C, D, E, so just go ahead and poll in when you're done. So that's about 1.5 minutes, which is about how long we should spend on these. I have about half of you have answered me so far. If you're agonizing between a couple of choices, now is the time to pick one. As a general rule, guys, this is a rule I hold myself to. Once on a verbal question, once I've narrowed down to 2 answers, I let myself look at each answer one more time, but then I pick something and keep going. Otherwise, what you find is you blow a bunch of time agonizing back and forth and back and forth and back and forth, and chances are you end up picking whatever you were leaning towards in the first place before you started the agonizing back and forth. So just go ahead and pick it. And if you haven't already, go ahead and pull in up here. I've got it says A, B, C, D, E now, since we've got a regular question this time. So we have got a split on this one. We've got A's, C's, and D's. I've got 2 votes for A, 2 votes for C, and 3 votes for D. So D wins with 1 extra vote, but it's pretty close here. This one I do think is quite tricky. So first of all, we need to identify the kind of question we have. Luckily on this one, that's very easy because they just say it right there for us, weaken the author's conclusion. That means we need to know what the author's conclusion is. So grab the highlighter for me, go into the little passage here, and highlight the conclusion for me. What is the author's conclusion? So orange will sell over 5 million units. Oh, and now we're getting highlighting on the whole sentence. So is it just the second half of that sentence after the comma? Or is it the entire thing starting from if 1/4 by the E-Slate, then orange will sell over 5 million units? What do you guys think? So we've got an if-then statement there, right? For an if-then statement, is the conclusion the entire thing? Or is it only the then part of the if-then? What do you guys think? I've got one vote for both. I've got another vote for the then part. And nobody else is typing. All right, so everybody's got to weigh in because I've got an even tie here. I've got one person who says, I think it should be both pieces. And another person who's saying, nope, it's the then piece. If you don't know, just say, I have no idea. You tell me what they want on this. All right, I've got a question mark. So what they want, and it really is a matter of just knowing what the test writers want, right? What do they consider the conclusion? So on an if-then statement, they consider the entire thing the conclusion. So that's something you want to keep in mind for future. If-then means not just that the then part is going to happen, but if this thing happens. It's not just that they're going to sell 5 million units. It's that if 1/4 of the people buy these, then they'll sell over 5 million units. So it's this whole piece of it. So that may or may not change things for you, but just know that it is actually the entire if-then statement that we need to pay attention to. Okay. So they give us a bunch of data, and they're going to sell their product to these different people, and so on. And then if 1/4 of all these people we're talking about buy the thing, then they'll sell over 5 million units. Okay. Did you guys identify, before you went starting to look at the answer choices, did you identify any weaknesses? So since they were asking us to weaken. And the person who told me the then only is the person who highlighted the whole thing. See, so don't second guess yourself. It was because I asked you and then you were like, wait, maybe I'm wrong. Did you think you were hearing something in my voice that was telling you it was one way versus the other? I'm really good at pretending that it's one way versus the other when it's the opposite, just to see if you're giving me your own opinion. Remember that question about the boss who doesn't want people who suck up and say what she wants them to hear? I'm trying to trick you to see if you'll stick up for your own original thoughts. So you were totally right in the first place. It's the whole thing. Okay, so it's a weaken question. We want to weaken it. Did you notice any weaknesses in general in the argument where you went, well, I don't know about that? Because that can just help sometimes when you're looking at the answer choices. So if you did notice anything, you don't want to spend a ton of time trying to brainstorm those, but if you did notice any flaws or assumptions, you'd want to just make a note of that, because that might help you when you're assessing the answer choices. Okay, so Hannah's saying, so they categorized the market segments by different criteria. One was by income, and then one was by profession. Okay. So we've got medical professionals, and then we've got people making over $250 a year. Is that, if that's a weakness, how? So what's that messing up there? I'm going to change our chat back to group. Back to the whole group here. So now you're chatting to the whole room now. So that for this discussion, I don't have to repeat everything you type. So is there a weakness in having one thing be categorized by profession, but another thing be categorized by income? When I'm talking about these groups of people who I think are going to buy my eSlate. A 3D eSlate, that sounds pretty cool. There's overlap or potential overlap. We don't actually know, right? But there's potential overlap in the categories. So if I've got somebody who's a medical professional who's making more than $250,000 a year, did I count that person once or did I count that person twice? I don't really know. But it kind of sounds like from the next sentence that they counted the person twice because they added up the number of medical professionals plus the number making over $250 a year. So it sounds like I might not actually have 20 million unique people. I might have fewer people. Okay. So that's interesting. Okay. So what does that call into question? The fact that there could be people who are double counted here between the medical professionals and the people making $250 a year, $250K a year. What does that actually call into question then? What's the sequence of events here? So those two things tell us the 20 million thing. And then how do we use the 20 million thing? So I've got the 20 million thing, and then I take 1/4 of 20 million to get 5 million. Okay. So, so if this number were really, say, 10 million instead of 20 million, what would happen? Follow through what's typed there. If that 20 million were actually 10 million, what would happen? I'm going to actually erase this highlighting here so that we can see this a little bit more easily. But what would happen down here if it were actually 10 million? Then the statement would become, if 1/4 of the people in these target markets buy the E-Slate, the new target market is only 10 million now. Orange will sell over 5 million units. Oh, no, wait. No, it won't. It will sell 2.5 million units because 1/4 of people in these target markets is no longer 10 million, or sorry, 20 million. It's only 10 million. Okay, so there's one problem. It might not be the only problem, but there's one problem. Now, you may or may not notice something like that on the read-through. If you do, you want to think about it. But if you don't notice it, whatever, you just go ahead into your or if you don't notice other weaknesses, then you just go ahead into your answer choices. Now we had A's, C's, and D's here. So just for B and E, again, grab the highlighter for me and highlight a word or a couple of words in B or in E that you thought was a good reason to get rid of that choice. So you read something in B that made you go, no, and you read something in E that made you go, no. Highlight for me what those things were. Education professionals, that's nice. It has nothing to do at all with the argument. They don't talk about education professionals at all. In fact, if you really wanted to take it further, you could then say, hey, maybe that would mean there were even more people who would want to buy it, and so they will sell over 5 million units. I don't know, something like that. But that's not going to weaken it. Okay, good. And let's see, people in the group that we want buy more electronic devices. Well, what does this do for the argument? If it's true that these people in this plus 250K plus category buy more electronic devices than others, what does that mean? For the argument, what does that mean? It doesn't weaken it. In fact, it just got a little bit better, actually, right? Like, I'm going to come in and be like, yeah, and guess what? And we can prove these people actually buy more electronic devices. That's definitely our target market. I just strengthened it a little bit. So let's get rid of that one. Okay, now between A, C, and D, what are we going to do here? So first of all, if you did think of this and you followed this chain of thought, then you would want to see whether one of your answer choices matches that. So if you did use this and you thought, okay, one of these answer choices actually does call out this flaw, that maybe the 20 million isn't really 20 million. Tell me if there is an answer choice that matches that. Tell me which answer choice that is. And Lauren's telling me that that's D. Let's take a look. Many medical professionals make over $250K a year. Oh, so this is pointing out that there's overlap between those two groups. So potentially that one's the right answer. Yeah, so potentially that one's the right answer. I know we've still got some people who are going with A and C though. And Ed, I think your comment there is targeted towards answer A, right? So I agree. So if it was only 5%, you would only, and if the 20 million number were right, then we would sell only 1 million units. Okay, now what was the conclusion again? This last sentence. They project that if 1/4 of people buy the E-Slate, then, there's no then there, but then Orange will sell over 5 million units. Do they say 1/4 of people will buy the E-Slate? So there's a difference between me coming to you and saying, hey, I'm confident I'm going to get 1/4 of the people in these markets to buy, 25% of the people in these markets to buy my E-Slate, versus coming to you and saying, hey, if I can get them to do this, I don't know if I can get them to do it yet, but if I can get them to do it, we're going to sell over 5 million. Isn't that awesome? Which one are we dealing with here? Have I predicted the number that I will actually sell? Am I claiming that I will actually sell this number or get this percentage of people to buy? Or am I just saying if I can somehow figure out how to get this percentage of people to buy? then that's going to give me X number of units sold. Yeah, that if is a big difference there. So the way I would word it, if I had wanted to do the first thing that I was talking about, which was I am actually going to get them to do this, is Orange projects that 1/4, so I'm going to do a little surgery here, that 1/4 of people in these target markets will, we're going to put a will in there, will buy the E-Slate, and therefore Orange will sell over 5 million units of the E-Slate. What's the difference if I change it that way? Orange projects that 1/4 of people in these target markets will buy the E-Slate, and therefore Orange will sell over 5 million units of the E-Slate. If that were the wording, I would pick A as the answer, if that were the wording. But it's not the wording. So what's the problem with A? A, sadly, is I wanted to pick A in this one. In fact, when I did this one and I read A, I picked it. Well, I mean, I wrote down, okay, it's A, and then I got to G, and I was like, oh, wait. And then I had to go back and forth between A and G and realize, oh, damn, it doesn't say. It doesn't say. So annoying, I agree. It doesn't say that they will get 1/4 of the people to buy these. Their prediction is this if-then statement. And this is why I was making the point at the beginning that if we have an if-then statement, we have to go with the entire conclusion. It's not just that they will sell over 5 million units. They're not actually saying, I will. So I'm the new sales director. I'm not saying I will sell 5 million units. I'm saying if I can find a way to get 25% of people in these markets to buy my E-Slate, then I will sell over 5 million units. What this does is this says, oh, only 5% of the medical professionals are going to buy it. And then I would go, damn, well, I guess I didn't find a way. It doesn't weaken my conclusion, because it just means I didn't find a way to get these 1/4 of these people, 25% of these people to buy the stupid E-Slate. But if I could, would it still be true that I could sell over 5 million units? Well, if this were the only new piece of information that I had, sure. So really, really annoying. And it doesn't even necessarily call into question the premises. Again, this makes no claim about whether or how many people will actually buy it. It just says if. It's just saying, if this happens, then there's something and that's it. And that's a different kind of statement than saying, I am going to sell this many. This many people or this percentage of the people will buy my product. That's a completely different statement. So you got to be really careful with these if-then statements. This tears down the idea only that I will sell over 5 million units. If that were my total conclusion and that's it, then yeah. But I didn't say that. I just said if I can get 25% to buy, then I'm going to get my 5 million units. This doesn't tear down that if-then. It just says, oh, I guess I'm not going to succeed. But I didn't claim that I was going to succeed no matter what. I only claimed I was going to succeed if I got the 25% to buy. So that's a really subtle point. Let me know if you're okay with that, if you see the trap that they set for you there. If you have any questions about that, raise your hand, start typing, let me know. I understand, but I don't like it. I agree. I think it's a really tricky little trap. And this is where I want you to be careful from now on whenever you see a conclusion set up as an if-then statement. Know that it's both the if and the then, and that what you're really going to be trying to tear down is the idea that this if leads to this then. That's pretty much on if-then statements what they're going for. Does this if actually lead to this then? Well, if we look at answer choice D, no. This if does not lead to this then if answer choice D is true, right? If answer choice D is true and that actually makes this number smaller, then even if the if still happens and 25% of the people buy the E-Slate, the then still won't happen, right? So that's what you're actually trying to pick apart or tear down on these if-then ones, is that link between the if and the then. Okay, so smiley face if you can live with that and you can remember it and you can, learn to do that for future to deal with that. Again, if you have any questions about it, start typing, let me know. And then the other one I just want to talk about here is for C. This says that they've generally been, that previous projections have generally been too optimistic. This could potentially weaken. The idea could basically be, oh, you're being too optimistic, so you might be wrong, but the same reasoning actually that we used for A applies for C, which is that I'm not again saying that I will sell over 5 million units. I'm only saying that if I can hit this certain target, then I will sell 5 million units. This part doesn't specifically tear down that if-then connection. The only one that does is answer choice D, because it says that my numbers were wrong in the first place, because there's overlap between these two groups. Okay. Any questions on that? So we have one last set to do for the evening. We're going to do an RC passage, and we're going to do some questions on it. If you have not already, I need you to go log into your Student Center. Sorry, we should have mentioned this at the beginning of class. I forgot. Go log into your Student Center. You want to download the reading passage that is in there for Class 8. So go to the handouts for Class 8. Download that passage. I'm going to ask you to give me a green check mark when you're done, just so that I know everybody's got the passage. It says Physical Science Passage at the top, and the first couple of lines are many chemical reactions produce. Many chemical reactions produce. So that's the passage that we want. Don't start reading it yet, even if you've got it already. Hang on a second, let everybody get it, and then we will, I'll give you guys a chance to read it and diagram it, and then we'll do a couple questions. So green check mark again when you've got it. And let us know if you're having any trouble finding it or downloading it. All right, I've got green check marks from almost everybody. Ed, do you have it, or you haven't tried any trouble getting it? Just let us know if you're having any trouble. So what I'm going to do, guys, is I'm going to give you 2 minutes to go ahead and read this, diagram it, the whole deal. I'm also going to put your first question up on the screen. So you're going to do this like you're doing it just on the real test, okay? So go ahead and read it. When you are done with that and with the question, I'm going to ask you to give me another green check mark, okay? So go for it. So that's about 3 minutes. That's 2 minutes to read the passage, take some notes, a minute to do this question. It might take a minute, minute and a half on the question. It depends whether you like science passages and how much you get into it. I have responses, or I have green check marks from about half of you. If you are done, go ahead and give me a green check mark, by the way. If you're still working, hopefully you were continuing to work while I talked about that. Now that puts us at about the 3.5 minute mark, which is about what we're looking for here. Okay, so we've got this really annoying science passage. Let's talk first. Go take a look at the passage itself. And what I want to talk about first, and I want you guys to just tell me in the chat window, is in your own normal non-chemoluminescent words, I want you to tell me, what's this thing about? So let's start with the first paragraph. If you could, in one kind of shorthand sentence, tell me what the first paragraph is about. What would you say? Or tell me what you wrote down in your notes. And I know that might take you a second to type with these words. Hopefully they'll use abbreviations. I really, really hope that nobody wrote down chemiluminescent or whatever on their scrap paper. So mechanisms, 3 mechanisms for generating light and heat, 2 different types of chemical reactions. So they start out with this very generic sentence, many reactions produce visible light. This CH thing, and don't even write chemolum. Write CH. Make it easy on yourself. You'll remember for the next 3 minutes while you're doing stuff that CH means this word that we can't even pronounce. Okay, so in contrast to, now what does this mean? So they say, however, in contrast to typical exothermic reactions. Okay, so in contrast to, I'm going to get a contrast, typical or normal exothermic reactions, such as combustion. What's such as mean? What are they telling me about combustion? Define combustion. It's an example of the typical exothermic reaction. Okay, good. So that's an example in which light is an unimportant byproduct. Okay, detail of combustion, which is a typical, blah, whatever. Okay, CH reactions, such as those in fireflies, yield light but little heat. Okay, so we've got these exothermic reactions, and some are typical, and some are not, basically. So we've got typical, and then we've got the atypical, which is the CH thing. Okay. The physical products of any exothermic reaction, detail. All right, so we've got a bunch of stuff in there that talks about the typical exothermic reaction and then how the CH reaction differs from that. And then what about that second paragraph? Why is that one sitting there? What's the purpose of that one? So it's a continuation of this CH thing, yeah. So now they're not talking about the typical exo and doing a comparison or contrast really between the typical and the CH ones. Now they're diving more into some weird CH thing with the dark quenchers, whatever those are. Okay, so more details on the CH stuff. Okay, so just want to get that straight before we start looking at these questions. Okay, so for this first one, I'm going to, again, hide your chats. We're going to call these A, B, and C. We need to do an all that applies thing on this one. So on this one, tell me in the chat window which ones you picked. A, B, C. If you only picked one, I guess you can go ahead and show me that in the regular polling, but if you picked more than one, then show me that in the chat window. All right, so it looks like, okay, good morning. I was going to ask you to do that. I saw the and, but then there is no letter before it. Thank you. All right, so it looks like everybody agrees, everybody who's typed in the chat window likes A and C, and then some people like B and some people don't. So let's see. So for answer choice A, it releases energy. So they're asking me what is always true. So there's two things I need to focus on here, the word always and the word true. I need to find something that's true of an exothermic reaction, meaning the passage told me that it's there, that it's true of this kind of reaction. And not just that it's true, but that every exothermic reaction is this way, that it's always true. Okay, so for A, everybody picked it, it looks like. Where is the proof for this one? Give me the line number that tells you that A is always true of an exothermic reaction. And I've got a vote for line 3. If we go and look at that, that's the line that says typical exothermic parentheses energy releasing. So when we use parentheses like that right after a noun and we're putting an adjective in there, we're describing that noun. So exothermic parentheses energy releasing means exothermic is the same thing as energy releasing, or it releases energy. So you guys are exactly right. This is one of the ones we would want to check here. C also, everybody likes C. We'll talk about B last since that was the debatable one. So C, its products have lower inherent energy than its reactants. Again, tell me the line number that gave you that evidence. What is the line number that gave you that evidence? We've got 9 and 10 there. Let's go take a look. So 9 and 10 are, and I'm going to extend that to 8 because there's a very important word in line 8 that allows this to qualify. The products of any exothermic reaction. Remember, it's got to be something that's always true, so we really need that word there. So any exothermic reaction have lower inherent chemical energy than the initial ingredients, and initial ingredients is just a synonym for reactants. Okay, good. So that one definitely, I agree, is one that we need to check. And then for B we had debate on. It yields significantly more heat than light. So for those of you who liked B, give me the line reference that proves it. For those of you who didn't like B, tell me why you think that's not always true. So again, if you liked it, prove it. Tell me the line number. And if you didn't like it, give me your reasoning for eliminating it. So I've got one saying, it does not directly say that this is always the case for every exothermic reaction. Let's see. In lines 5 and 6. Okay. Oh, and you're talking about answer choice C there too. Okay, I'll go back to C in a second. Okay, so for B, B does talk about some yielding, well, this one's a little bit strange. This is where for B we have to get a little bit more into the details of what's going on here. So they tell us that typical exothermic reactions yield light but little heat. But then they, or sorry, I'm skipping something here, in which light is an unimportant byproduct. Typical exothermic reactions in which light is an unimportant byproduct. It doesn't say that it's a minimal byproduct or that it's not there or barely there. It just says unimportant. That's a judgment call. In an unimportant byproduct, the CH reactions yield light but little heat. And the thing is, the CH reactions are also a type of exothermic reaction. They both are. So the typical ones yield, or light is an unimportant byproduct. But the atypical ones, these CH reactions, they're still exothermic reactions. So they yield light but little heat. So that one we can't say is always true because it's not true for those CH reactions. Then I had a question about answer choice C, taking a look, let's see. I thought it wasn't always true because of lines 11 and 12. Let's go take a look at 11 and 12 here. However, in combustive reactions, this difference in energy is discharged primarily through random molecular motion, macroscopically perceived as heat. I see. Okay, you thought that maybe because of the word however there. I'm guessing, is that right? Okay, so what they're actually getting at there, they are giving a contrast there as evidenced by the word however. You were right about that. So basically what they're saying, the first half of that sentence before the semicolon is saying that what you produce has lower energy than what you started with. So if you remember all the way back to chemistry 8 million years ago, and we had what were called the reactants and the products. And there was like, energy curves and where do you lose energy or where do you gain energy or whatever. And so what the first half of that sentence is saying is that the energy of the reactants is going to be higher than the energy of the products. I'll just use some arrows to illustrate that. The second half of the reactants, of that sentence is telling us just how in a certain type of exothermic reaction, the combustive reaction, the way in which that energy gets dissipated or discharged. So they're telling us it gets discharged as heat. So they're not saying that it's not that this isn't true. It's just giving us more detail about how it happens, basically. Where in the CH reactions we're getting a lot of light, it's mostly getting discharged as light. In the combustive reactions, it's mostly getting discharged as heat. So yeah, that however there is they're trying to throw you a little bit. And it looks like it worked on that one, but the first half of the sentence is still true or is still the case. They're just adding more detail about the distinction between the CH reactions and the combustive reactions. And I've got a question too. First paragraph has 2 sentences. Each one is 7 to 8 lines long. I find this difficult to read. I agree. Very long sentences, especially in science passages, are not uncommon. When that happens, try to find some noun that you actually understand. So when you're reading it and you're like, I don't know what they're talking about, find some noun that you understand. And then look for adjectives to describe the noun, just to understand, and look for verbs that go with the noun to understand whatever action the noun is undergoing. And kind of do that with nouns and adjectives and verbs, and then see if you may have 2 or 3 of them in a sentence, right? And then you would see how they actually fit together. So you're looking at, you're almost breaking the sentence down into pieces and looking at individual pieces or individual actions in the sentence. And then once you get that, then trying to put the whole thing together. Also look for punctuation marks. So, for example, in that second sentence, the one that starts, however, in contrast to, we've got a number of punctuation marks and a number of clues that indicate detail. So we've got in contrast to exo. So in contrast to, I know something else is coming up, there needs to be an A and a B. My A is the exo reaction. There's got to be a B somewhere, so I'm waiting for it. Such as indicates an example. So let's just skip that for right now if I'm having trouble understanding the sentence. In which is giving me more information about that example. Well, if I'm still trying to understand the basic idea, forget that right now. So I'm going to, everything between the commas between in which all the way to byproduct, I'm going to ignore. So now I've stripped it down to, in contrast to typical exothermic reactions, comma, skip the rest of line 4, skip all of line 5. CH reactions, such as, skip, example, yield light but little heat. So I've just stripped out half the words in the sentence, maybe more. And I'm just going for the basic nouns and verbs. That takes some practice to do. It's not something you can just do, in the moment. But that's something that if you practice it, you'll get better at it, and you'll be able to start to just strip out all the extraneous stuff and get the basic idea of what's going on. But that is definitely going to take practice. Yeah, no problem. Any other questions about this one, guys? So the two that are always true are A and C on here. Some exothermic reactions do yield significantly more heat than light. That's true, but not all of them. Not always. And so that's why B is not true. Any questions on that one? All right, I'm going to give you one last one. We're going to make this one a quick one because I'm a couple minutes over and I don't want to take too much time from Liz. But this one we've talked about a little bit. It's in that same general area, so hopefully it shouldn't take you too long, although it can still be a little tricky. Go for it. You can just put your answers directly up here in the polling when you're done. All right, and that's our time on this one. Our most popular choice on this one is answer choice A. So this one is something we call vocab and context. They give us a word, they give us a line reference. And then note also that this one is what we call a why question. It's not what word did they use or even exactly what does this word mean. It's why did the author bother to include this word in the text. One technique that often works really nicely for this is to go find it, read it with the word in there, and then cover up the word with your finger or just mentally block it out and ask yourself, how would this change? How would the meaning change if I didn't have that word in there? What would happen? So if we go and take a look, it says, in contrast to typical exothermic reactions, CH reactions yield light but little heat. Notice what I did there. I stripped it down to the basic sentence. So in contrast to typical exothermic reactions, CH reactions, so what are they getting at there? Just in your own words. Why is that word typical there? And how do you think things would change if the author hadn't put that word there? You can answer one question or both. But why do you think that word is there? What do you think? What purpose do you think that word is serving? And if it were removed, what difference would that make? It's saying because it's doing this contrast thing, it's saying that the CH is not typical. So in contrast to something that's typical, these other things, those must not be typical. Good. The exothermic stuff, like the combustions, are more common than the CH stuff. Yeah, so they're using it as part of the contrast. The first type is more normal, the second type is more of the exception. Good, good, good. Okay, and so when we look at our answer choices, the one that matches what you guys have just told me is, I'm going to highlight the word right here, is answer choice A. They didn't use the exact words that we used. That's okay. Not typical means something that's unusual. Not typical means something, or something that's not typical is something that's more of the exception. So basically, they're just trying to highlight the contrast between the one type, the more typical exothermic reaction, such as combustion, and this other CH reaction that they're going to spend the rest of the paragraph telling us about. For this one, we can go through and eliminate answer choices as well, but you'll notice that it's easier on this one if we can to go into the passage, try to figure out what we think it means and why it's being used, and then look for a match. And what you can do is look at your 5 answer choices and go, does this mean something that's not typical or something that's the exception? Does this mean something that's not typical or something that's the exception? And so on. And then the only one that matches on that one is answer choice A. I do want to address answer choice E because a couple of people picked it. Everyone was between A and E on this one. So this one says it's in order to position exothermic reactions within a larger hierarchy of reactions. Now, a hierarchy is like a classification of different kinds of reactions, right? So far we've got the combustion reaction, which is the more typical one, the chemoluminescent reaction, which is the less typical one. Both of those are exotypes of reactions. A larger hierarchy would imply that I've got other things that are above or on the same level of the exothermic reactions. And they haven't given me that information. They haven't given me a hierarchy or other things in which the exothermic stuff is just one small piece. So that one takes it too far. Any questions on this one? This is our last one for the evening on verbal. We're going to switch over to some quant. Any questions on this one or on the passage stuff in general that we've been talking about? If you're good to go and you're sick of verbal, give me a smiley face or maybe a frowny face. If you have any questions, start typing, raise your hand right now, let me know. And I'll hang out at break 2 to answer any questions. Okay, I'm going to pass it over to Liz. We'll take a break and we'll dive into quant.
All right, thank you, Stacy. That was an excellent run through the verbal review. We are now going to go and take a brain break before we do math. So we've got a lot of math to do, but let's make it 5 minutes. Let me know if you want to go out through the blue door, fine. Let me know if you're gone so I don't call on you if we get started before you get back. And we will come back and we will have a wild time with number properties. Woohoo. Here we go. See you soon. All right, welcome back. We're now going to get started on number properties. And I want to share my experience with number properties from the new GRE. What I found was that there weren't too many of these questions on the medium section, but that there were a sizable number on the hard section. And they were some of the questions that actually took me the most time that I really had to think about. Number properties is really interesting because it's based on not even high school math, but really middle school math, stuff like, you know, the least common least common multiple, greatest common factor. All right, but you have to reason about this stuff in, yeah, pretty sophisticated ways, in ways that you never saw in middle school. I mean, this is really, these questions are some of the most puzzle-like and perplexing on the GRE. You really have to think these out, okay? Although the basic math behind it isn't hard and will leave you sometimes scratching your head saying, why did I have such a hard time with that? All right? And so I would say that, you know, we're doing this towards the end for a reason. It's not really the core of GRE Quant, but it becomes very important if you're hoping to get a high score on Quant because they use these sort of puzzle questions to distinguish, I think, just judging on how many of them I saw in the harder quant section. Okay, so just give me a quick idea. How many of you were able to read this material or at least skim it, do a couple problems? Give me a smiley if you were able to get through some of this material. All right, you can give me the blue face, the sad face if you weren't able to get through. Okay. Okay, so even if you weren't able to get through this material, it's a little different than the probability and combinatorics in that you can track it. You do understand the basic math. So what I'm going to really encourage everyone to do, especially if you weren't able to read techniques, is to really focus on understanding the problem. Figure out what it says. What could you do with it? Spend more time sort of upfront thinking before you try to solve. Okay? So I'm going to just put up our first question, and we're going to just try this. It's a divisibility question, and we're going to see how this goes, okay? So I'll set chat to private, and you can just text me with your answer. Here we go. Okay, so I know it was tough because I only got answers from 3 people. Let me make chat public. Okay, so first of all, what does this mean? If the positive integer n is divisible by both 4 and 21, then n must be, let me highlight this critical word, divisible by which of the following? All right, so anybody type into chat, what does it mean? And what might an approach to this be? Okay, you don't need a specialized approach. First, you just really need to figure out what is it actually asking. All right. I see a couple people typing, Lauren and Adam. Let's see what we have to say about this one. What does it actually mean? I think that's often the hardest part with the number properties problems, just figuring out what is it actually asking you to do. Yeah, which of these answers are factors of n? Exactly, Adam. Now that's excellent. So from that, yeah, well, you thought it was asking if these numbers can be divided by n. Careful, Lauren, it's can n be divided by these numbers, right? It's just the reverse of that, which may be what you meant. Okay. All right, so it's tricky. So how would you figure out what n has to be divisible by? Must be. This is a key word in math. It has to be true. I know that n is divisible by both 4 and 21. There are a couple of approaches I could use. One thing is just, what is the smallest number that n could possibly be? Yeah, Lauren, you could multiply 4 by 21. Okay, and that would work in this case, but not in all cases. All right, because here, yeah, absolutely, the smallest possible n is 84. But what if I asked you if the positive integer n is divisible by both, say, 4 and 6? Okay, then what would the smallest possible n be? Okay, now think about it. If n, a little different, what if n were divisible by both 4 and 6? Okay. Yeah, it could be 12, right? It could be 12 if it were divisible by 4 and 6. Yeah, Ed has got it. You would want a factor here, okay? Because what you're really looking for, this question is really asking you to figure out the least common multiple of 4 and 21, okay? And the way we would do that would be with factoring. Ooh. Okay, so I might take a 4 and I might take a 21. Then I'd say, okay, so the 4 breaks down to 2 and 2. The 21 is going to break down to 7 and 3. Okay. So n, all right, and this is just an easy way to do it. I could multiply 4 by 21 first and get 84, but then I make more work for myself because then I have to test and divide all of these into it, and that's going to be a lot harder. When I just look at the factors here, I say, okay, so n equals 2 times 2 times 3 times 7 times something, right? Where something is an integer. Okay, so then I think, well, what divides that? Well, you know, obviously 2, right? Does 8 necessarily divide that, guys? Here, I'll turn chat private and you can tell me yes or no. Does 8 have to divide into this? Just looking at it. Okay, anybody? Tell me, talk to me. Chat's private, don't worry. Yeah, Lauren is saying no. It doesn't divide it, right? And there's a really easy way to test that. If you think about it, if you factor 8, you know, 8 breaks down into 2 times 2 times 2, right? And if I just, you know, made a fraction out of it, all right, I'd realize, oh, I don't have enough 2's to cancel, so it's not going to work. Okay, so 8 doesn't work. But what about 12? Can I figure out if this number has to be divisible by 12? Okay, just think about it. Yeah, it does have to be divisible by 12. Exactly, Hannah. Because you've got this 2 times 2 times 3. Oh, that's 12. So n is just 12 times something. Yeah, excellent. All right, so 12 works. How about 14? If we look at 14, what's the key? 14 actually does work. I'll give you a help. But what's the key? How do I know just by looking at it that 14 works? How do I know, guys? I look at this, I see the way I've written n out, okay, and I know that 14 has to divide it. Why is that? Yeah, thank you, Lauren. Exactly. Okay. Now 24, does 24 work? What about 24? How would I figure out if 24 worked? Okay, think about it. Yeah, it doesn't work. Adam's got it. And the reason I know that it doesn't work, again, I could factor 24. It's 2 times 12. All right, so that's 12 I already know is just 2 times 2 times... Yeah, exactly. Hannah has it. If you just factor the number, I know that it's 3 2's and 1 3, and I don't have that in n. I don't know for sure that I have it, so 24 is not going to work. How about 63? How about 63? 63 is pretty easy to factor if you know your times tables. What does 63 factor into? Yeah, exactly. Thank you, Hannah. Okay, so knowing your times tables is very helpful. So if I look at that, I realize that that can't divide n either. Okay, because I only have 1 3 for sure in n. Okay, now questions. Why was this a struggle? I did get a correct answer, but most people either didn't answer or didn't answer correctly. All right, think about it for a moment. Anyone have any insights on what made this problem hard? And I got one like this on the advanced section, by the way, very similar to this. What made it hard? Okay, whenever we see a problem, factoring made it easy. Yeah, Hannah's got it. Factoring is a really powerful technique with this type of problem. When you see something asking you about divisibility, you know, in your mind you should see this word and you should think factor. Okay, there should be this association, sort of like Pavlov's dog, hear the bell, salivate. All right, so see divisible, think, would factoring help? Okay, because it almost always will. All right, everybody remember what factors are? Sometimes people get confused by factors and multiples. Another way they can sometimes ask this question is to ask you about multiples. N is a multiple of what number? Okay, and it's very common under test pressure for people to reverse factor and multiple. There's a nice way to remember it. Fewer factors, more multiples. Factors are the ones you break the numbers down into. Okay, Let's try another problem, sort of similar. This next one is a QC. All right, and we'll just use the poll-in answers. So again, we'll take our usual, we can do this in a minute. This one's not so bad. Let's try this out. Okay, try it out. Oh no, no one has polled in an answer. All right, come on, poll in. Okay, if you're tired, just get some deep breaths of air, get another cup of coffee or something. All right, how do you factor divisibility? We're asked for the greatest prime factor of 126 and the greatest prime factor of 128. So how do we factor quickly? Okay, this is really just a test of factoring. Do you remember how to factor when you have a big number? What's a good technique when you have a number like this? Okay, it's not something you would know off the top of your head, like 12 or 9 or something. What's a good technique? All right, anybody have a good technique for us? Because you know what you have to do is factor it. And primes, everybody remembers primes. Right? We talked about primes before. Not a big deal. So how would we factor quickly? What's a good technique? Somebody help us out. Yeah, start by dividing by 2 since it's even. Start with the small primes. Okay, 2, 3, and 5 are nice. Okay, and remember, they rigged this so it would work. So then I get, 2 times 63 and 2 times 64. Okay, now I'm all excited. What's so special about 64? I don't even have to go any further. All right, what is so special about 64? When I start factoring this side. Yeah, it's 2 to the 5th. I might have recognized 128 as 2 to the 6th, but I for sure should recognize 64 and 32 as powers of 2. Okay, so the greatest common factor, prime factor of 128 is just 2. All right, yeah, 8 times 8, Lauren, excellent. If you know your times tables, absolutely. And then you know that the greatest prime factor of 8 is going to be 2. So then with 63, we just know it's 7 times 9. So what's our greatest prime factor of 63? What's our greatest prime factor? 9 you can break down. Okay, yeah, it's just 7. It's just 7. Okay, so this has to be the bigger one, and the answer is A. Ah, now I see a bunch of right answers. Excellent. Okay, so in terms of difficulty, why was this one hard? Why were we slow on this? What was the challenge? Anybody have an observation, or was it just that it's late? All right, if ever you're slow on something, if I look at this one, I think this is actually quite a bit easier than that first one. This should have been pretty fast. Late at night, okay, Jose. Factoring is slow. All right, so Meredith, the key here, 2 things will make it faster. One is practice, and the other is really knowing those times tables and recognizing special numbers like your powers of 2. All right, if you see 63 and you immediately think, ah, 7 times 9. Oh, okay, Lauren. Yeah, I like the technique, so let's write down techniques for factoring. Okay, start with small primes. Okay, so 2, 3, and 5. And on the GRE, they want it to be workable, so usually the numbers are divisible by at least one of these, 2, 3, and 5. The other thing I'm going to say is know your times tables. I know they give you a calculator, but it really doesn't help so much with this type of problem. You really still have to know those times tables. and that'll speed you up. And the other thing that comes up a lot, powers of 2. Know your powers of 2. The GRE seems to have some sort of a strange obsession with powers of 2, I guess because it, they break down into more 2s. 2s are the smallest prime. I don't know why, but for some reason they love them, and it's good if you recognize them. It'll help you with a lot of different problems. Okay? So this is something that I would say is not a hard problem. This is the kind of divisibility in primes problem you'd see on the medium section. So everybody should be able to do this quickly and efficiently. All right, now let's take a look just at one more, sort of a more challenging and interesting twist, but very, very doable. Think for a moment about what you need to do to solve, and then go for it. All right, so let me put up, we'll do the minute and 15 here. Okay, try this out. All right, not many answers, only a couple of answers, okay? Let's take a look at this and let's figure out how we would answer. First of all, how do you figure out the least common multiple of 2 numbers? We've got 2 numbers, 12 and 16. How do we get their least common multiple? All right, and because we're doing divisibility in primes, it has something to do with factoring. Break it down. Excellent, Lauren. Yeah, so I would take both numbers and I would break them down. Now 16, because I've already memorized my powers of 2, I know is 2 to the 4th. All right, it's just 2 times 2 times 2 times 2. Okay, and certain numbers will come up over and over again on the GRE. They don't want to make this computationally impossible. So 12 is 2 times 2 times 3. So how do I get that least common multiple? And I always thought it was funny. The least common multiple is the big one. It's the greatest common factor that's the smaller one. How do I get the least common multiple? What is the smallest number? Okay, shared factors are going to be the greatest common factor, Hannah, but what is the smallest number that is a multiple of 12 and a multiple of 16? Yeah, Ed's got it. Okay, it's 2 times 2 times 2 times 3. Okay, Lauren, the 2 is the least is a factor. Okay, and this is where it's confusing, factors and multiples. And this is just an unfortunate thing with mathematical naming. The least common multiple is the big one. The GCF, or the greatest common factor, is the small one. Okay. All right, so I'm trying to find a least common multiple of 12 and 6. Sorry, 12 and 16. This has to be bigger than 16. It's got to be. It's got to be at least 16. Okay, it's got to be at least the bigger number. But the least common multiple is just it has to be at least a bigger number. And what I have to do is I have to find some number that both of these, both 12 and 16, divide so I construct it. All right, so 16 has 4 2s. 12 only has 2, so we need at least 4 2s. 12 has a 3. I need at least 1 3. Okay, so we end up with this number that we know is 16 times 3, which you can punch into your calculator and multiply out, right? Or you can do what I do and just do the places and say, okay, so that's 30 plus 3 times 6, which is 18. All right, and you come up with 48. All right, now how do I compute the greatest common factor of 48 and 96? There is something that I see right away that gets me all interested in 48 and 96. Greatest common factor of 48 and 96. Anybody see anything interesting relationship between 48 and 96? Right, anybody see anything sort of fun? Yeah, exactly, Lauren. Lauren's got it. Yeah. 96 breaks down into 2 times 48. Okay. Yeah, okay, well, you see it in class so that you'll see it later on the test. That's part of the fun here. So what is the greatest common factor of 48 and 96? What's the biggest number that divides both 48 and 96? All right, which is another way to word it. Biggest number that divides both of them. It's got to be 48. Okay. It's 48. Okay. And here again, you know, we have 48. Okay. So our answer has to be C. Questions. Questions. What made this one tough? Looking at it. All right. Now someone is asking me, how did I come up with 30 plus 18? This is an old technique for multiplying. If I think about it, 16 times 3 is 10 plus 6. Here, let me write out the parentheses. 10 plus 6 times 3. So I can just do 10 times 3, okay, plus 6 times 3. Now, on the modern GRE, you can use a calculator, but these were skills honed way back when they didn't give you a calculator, all right? And so this is a fast way to multiply numbers. It's just a clever little trick. That was a privately asked question. Okay? Everybody see it? All right? It's just helpful sometimes to be able to do these little math tricks for quickly multiplying something without a calculator. Although on the actual GRE at this point, you could just punch in 16 times 3 to see this. Okay, smile at me if this is comfortable now. Otherwise, let's see the frowny face. Stacy's standing by in the chat window to answer questions. Now, I want everyone to practice this because these questions, if you've practiced it and you've thought about what it means, the biggest thing is remembering the difference between factors and multiples. These are actually not that bad, and yet they tend to be considered hard questions. All right, so this is a lot less work than some of those tough probability and combinatorics questions that we can see. And so I would highly recommend doing some practice here. And yet they seem to rate as just as tough. They're a lot less work, okay, if you see what you're doing and you quickly factor. All right, now I'd like to move on to a slightly different topic. Again, continuing with my theme of prime numbers being your friends, we're going to try a couple problems that test exponent rules, okay? And before we get too into it, what I'm going to tell you right off is with an exponent problem, you often want to take the numbers. If I have a number raised to a power, I want to take it down to prime bases. Okay, so if I have something like, 8 to the third, all right, I should realize, oh, that's just 2 to the third, okay, whole thing, because 8 is 2 to the third, raised to the third, okay. What is 2 to the third raised to the third? What is this equal to? It's 2 to the what? Anybody remember how you do this? Anybody remember? Type it into the chat window. You can just use the little caret for up arrow. How do we do this? I'll help. It's 2 to the third. I mean, it's just a notation that throws people off. Yeah, Lauren's got it. It's 2 to the ninth. And you can think about why. Okay. The reason it's 2 to the ninth, okay, and I see what you did, Ed, is that you're multiplying 2 to the third times itself 3 times. So then you add these up, and that's 9. So the shortcut way to do it is just to multiply the 2 powers. Okay, and the reason you're thinking 2 to the 6th, I bet you're thinking about adding the 3 and the 3. Okay, and that's what you do if you are multiplying. If I were multiplying 2 to the third times 2 to the third, yeah, I'd add them. Now, they are out to get you with exponent rules. They really are, because everybody forgets them. You learn them, you know them perfectly in, 6th, 7th grade. Then you get a calculator and you never do them again, right? You never use exponent rules again. Okay, so you want to practice this. The calculator doesn't have an exponent key. You can calculate it on the GRE, but it's kind of painful and time-consuming. It's really important to just learn the exponent rules put them on flashcards, and just memorize it, especially if you want that high math score. They do like these exponent problems. All right, so let me put up one, and let's just check it out, see how we do. Okay. Try this one out. I'll set chat to private, and you can send me your answers. All right, so 3 people have sent me answers, and those 3 people all got it right, okay? But not everyone has sent me answers. Most people have not. So let's think about how would we solve this? If 8 to the x equals 2 to the 12th, what should I do immediately when I see that 8? What should I think? Look at that 8. Okay, good, you got it. Oh, not quite, sorry. Okay, what should I do? Change 2 to 8, or change 8 to 2, okay? I usually take things down to prime bases. In this case, you could rewrite either way. There are 2 possibilities. So I would normally say, aha, 8, that's just 2 to the 3rd, so I've got 2 to the 3rd raised to the x, okay? And then I have to multiply. Okay, so then that's really 2 to the 3x. Okay, and then I would say, all right, so 2 to the 3x equals 2 to the 12th. All right. So what does x have to equal at that point? What do you know? Yeah, Lauren's got it. Okay, at that point I know, well, 3x equals 12, so x has to be equal to 4. So x equals 4. Okay, now the other way to do it, which is cool, all right, x equals 4. Whoops, sorry, wrote the wrong thing there. Okay. All right, I like what Hannah did. You could change the 2 to an 8. All right, Hannah, so if I convert 2 to the 12th to an 8, what do I get? 2 to the 12th equals 8. Okay. Yeah, okay, so then I would break it out. Yeah, again, I could say, well, that's just 2 to the 3rd raised to the 4th, because 3 times 4 is 12. Okay, so it's just 8 to the 4th. Okay. And then x has to be equal to 4. You get the same answer. Again, sometimes the fun of math is that there are multiple ways to get to the solution. As long as you don't make any errors along the way, you're fine. Multiple different paths. Really, it just depends on what you see first and what makes sense to you. The key is not to lose track of your train of thought. All right, so now what made this tough? Okay, give me that blue face if you have forgotten your rules of exponents and need a brush up. Give me that blue face. I'm wondering if this is just forgetting the rules of exponents. All right, yeah, okay. So this is a warning. You know, if you've forgotten your rules of exponents, exponents are not that hard. These are considered mid-level problems on the GRE. They're not really hard problems. I'll put up a hard exponent problem, but this is something everybody has to be able to do. Okay, and this is just a matter of brushing up on those rules of exponents and remembering that little trick of going down to common bases, taking it to a common base, and then you can just compare the exponent. All right, smile if this is comfortable. I'd like to do a more challenging version of this problem. Blue face if it's not, if you don't understand at least one of these ways of getting here. Okay, now I'm going to leave this up and bring up the more challenging problem, okay? And you can use this to help yourself think about how to solve the more challenging problem. All right, so here is our friend, the more challenging problem. We're going to take 2 minutes to do it, all right, and text your answer to me. Whoops, okay, so I've only got a couple of answers, okay? And I think this problem was pretty tough for a lot of people, judging by how few answers. So I'm going to ask you, when you're faced with something like this that is just obviously not computable by hand, there's no way you're going to compute 32 to the 6th, even with a calculator. It's going to overflow. Okay, you should think there's a trick. What should I do? I see 32 and 27 on one side and 2 and 3 on the other. What's interesting here? All right, somebody tell me what's interesting here. You have to, when you see a problem that looks impossible to compute, step back and think for a moment. What could be going on? All right, what's going on with 32 to the 6th? 32 to the 6th. This is just too insane of a number. There's no way I have to compute this. Okay, especially if you didn't get it. Look at this and think, what's going on with 32 to the 6th? I've got 32 to the 6th, 27 squared, 2 to the x, 3 to the y. What should I see here? 32 and 27. What's special about these numbers? Number properties is a lot about what's special about numbers. Yeah, Ed and Lauren have it. Okay, I could rewrite this 32 to the 6th using my rules of exponents. I could say, hey, that's just 2 to the 5th. Okay, raised to the 6th. And with my rules of exponents, I know that's got to be, well, it's 2 to the 5th 6 times, so that's 2 to the 30th. Okay, so 27 squared. Okay, again, I can rewrite 27 as 3 to the what? Anybody? Think about 27. That is 3 to the 3rd. Yeah, Lauren's got it. Okay, so I've got 3 to the 6th. Okay, so 2 to the x times 3 to the y equals 2 to the 30th times 3 to the 6th. So x has to equal 30. All right, and y has to equal 6. So if I divide x over y, I get 5. Okay, so the correct answer is 5. And I'll write them in for everyone. Okay, now, looking at this, how many of you follow? How many of you see what I just did? This is sort of a magic step, going from here to this. Smile if you see how this one works. Blue face if you don't, all right? This is actually pretty typical of a hard section exponent problem, okay? And you can see that you've got to use the same kind of knowledge you used here for the sort of more mid-level one, except that the numbers are bigger. And that's usually the big difference. The numbers will be bigger, so it would not be practical to do it on a calculator, and that might be intimidating just to see the big numbers. But the rules of exponents are the same. Okay. All right, so that's a really good question, Hannah. How do I know that x has to be 30? Okay, so this is our prime factoring again. So if I say 2 to the x times 3 to the y, okay, and this is something cool, all right, is equal to 2 to the 30th, or cool to those of us who are nerdy. Stacy, I'm sure, thinks it's cool. Okay, 3 to the 6th. All right, so if I factored this monstrosity, We're both dark, Stacy. If I factor this, I'm only going to get 2's and 3's, right? Is there any way I could get a 2 out of 3 to the 6th? Hannah, is there any way I could possibly get a 2 out of 3 to the 6th? What does it mean, Stacy is asking. She's giving you a hint. She's giving us a hint. What does 3 to the 6th really mean? Okay. Write it out, guys. Type it in. What does it mean? Exponents are just notation. And they're hard because the notation is hard, but the concept underneath is not that tough. Yeah, there's no way I could get it. 3 to the 6th exactly. Lauren is saying it. It's 3 times 3 exactly. And Stacy's typed it out. There's no 2 in there. If I know that a number is 3 times 3 times 3 times 3 times 3 times 3, it's not a multiple of 2. It's a multiple of a bunch of 3's. Okay, so that's how I know. Once I get the numbers down to prime bases, okay, and these are again primes. Primes are the elements of numbers. They're the building blocks. You can't break it down any further than a prime. Okay, then I can't get anything different. All right. If I had a 6 to the something, well, I could get 2's and 3's out of that. But once I get down to 2's and 3's, I'm done. I've got the prime bases. And that's why we so often use prime numbers when we're working on these challenging number property problems. It helps us to simplify them, all right, into something easier to think about. Okay. Any questions? Jose, I see you are typing. Okay. So you got to the 2 to the 30th and the 3 to the 6th, and then you got lost. All right, so does it make sense? And Hannah's question was perfect. All right, does it make sense why this had to be? This whole thing is since 3 to the 6th is just 3 times 3 times 3, 6 times. 2 to the 30th is 2, 30 times. It has to be that we have 32's and 6 3's. Does that make sense? Smile at me if it makes sense. Otherwise, put up that blue face. Now it does. Okay. So a lot of doing number properties. It's not that it's so hard, but you have to really understand the stuff well. Okay. All right. It's tricky ways of looking at middle school math. You have to really know this stuff that looks pretty basic, but actually has a good number of subtleties well. Now, I have another challenge problem, another fun problem. I want you to see this. I got one like this on the advanced section. I was quite excited to see it. It's my favorite exponent trick. All right, and we're going to take a quick look at this. Okay, let's try this as a QC. All right, one thing, my hint here is that you know that you're not computing these numbers. You are not computing 3 to the 11th, 3 to the 12th, or 3 to the 13th. Think of another way to do this. All right, what could you use? All right, okay, one person saw the trick. What should you do here? There's no way you should calculate these. But look at quantity A, look at quantity B. What do they have in common, guys? What do you see that they have in common? Whenever you have one of these weird puzzle problems, all right, you have to find clues. 3 to the 11th, yeah, okay. So what can I do with that 3 to the 11th, Lauren? Notice, you know, B is 7 times 3 to the 11th. What could I do to A? 3 to the 11th is in common. You pull it out. Exactly. You factor it out. So 3 to the 11th times 3 is just 1 times 3 to the 11th minus, well, 3 to the 12th is 3 to the 11th times 3. Okay, plus 3 squared. All right. I love what Lauren did. She just factored it out. And then what did you do with it, Lauren? What did you do with it after you factored out that 3 to the 11th? Okay. Yeah, you could divide both sides by 3 to the 11th. Yeah. So now I have 3 to the 11th. That works. Okay, times 7. And Lauren remembered, you know, as long as it would work with an inequality, I can cancel. Yeah, you could divide both sides by 3 to the 11th. That works. All right, so now this is something that is realistic. 1 minus 3 plus 9, this is something you certainly can calculate. All right, and that's just 10 minus 3, which equals 7. Oh, they're equal. The answer C. Okay, clever trick. When you see something like this, okay, you should factor out the lowest power, the lowest common power. Here the lowest common power is 3 to the 11th. What are they trying to trick you into doing? What do you guys think? What are they trying to trick you into doing? Okay, when you see this common basis. Anybody know? What are they trying to trick you into doing? Anybody see it? Often it's really helpful to look at a problem and to think, how are they trying to trap you? Well, making you do the math would be an enormous waste of time, but a lot of people would look at this and think, okay, so that's 3 to the 11 minus 12 plus 13, all right? That is going to be 3 to the 12. And what did I do that was just a disaster here? What error did I make? What error did I make? Oh, sorry, it would be, what error did I make? Anybody see it? What disastrous exponent error did I make? Yeah, Lawrence got it. I can't add and subtract the exponents here. I can only add and subtract the exponents when I'm multiplying or dividing the bases. This is a math error. All right, and it is a very common math error with exponents. Okay, so we don't want to make it. All right, the GRE loves to trap people into math errors. Okay, this is how you do it. You factor out that 3 to the 11th. All right, smile at me if this one makes sense. Blue face otherwise. All right, blue face if you don't. Okay, if you're falling asleep, everybody let's just take a deep breath, just a little more of this stuff. Okay? Yeah. Okay, now we're going to do a couple problems with roots. All right. You know, maybe we'll start off with one root problem. Okay? Because there's some other things I'd like to get us through tonight. Let's try roots. All right, roots are very much like exponents. Really, a root is an exponent. It's a fractional exponent. And you use your rules of exponents to work with roots. Okay, so let's try this one out. Okay, here you go. Try it out. Oh no, only 2 answers. Okay, and you guys have it. You guys have it right. But when I see this thing, square root of 2 to the 36, would I ever have to calculate 2 to the 36? No way. Okay, so if you've forgotten how to deal with it, think about this. What if I had 2 to the 4th? How would I take the square root of 2 to the 4th? Anybody know? How would I take the square root of that? All right, anybody know? What's the square root of 2 to the 4th? Type it in if you know it. I'll help. 2 to the 4th is 16. What's its square root? In powers of 2. Oh no. Yeah, okay, Ed has it. Yeah, okay, so all you do to take a root, okay, when you have something that's already in exponent notation, you just divide, if it's a square root, you just divide this number in half, okay? Because the question, the square root is really saying, okay, what times itself equals 2 to the 36th? Oh, well, that's easy. That's 2 to the 18th times itself. 2 to the 18th times 2 to the 18th. Okay. is going to be equal to 2 to the 36th. All right? All I have to do, if the exponent is an even number, is divide it in half. Okay? If it's not an even number, I would get, say it were 2 to the 37th, then the square root would be, okay, so that's the same as the square root of 2 to the 36th times 2. I'd be able to divide the 36 in half, pull out the 2 to the 18th, and then I'd have a root 2 left. Okay? So here, this is 2 to the 18th. What about 64? Why is that number special? Why is 64 special, guys? What is special about 64? Yeah, exactly. Ed has it. It's 2 to the 6th. It's a perfect square. Yeah, good. It's good to notice these patterns in numbers. It's 8 squared. Okay. And you could have rewritten this. You know, you could have thought about, can I rewrite this as 8? Yeah, it's 8 to the 6th. All right. Or I could have just said, oh, wait, this is 2 to the 6th. Okay, so A has to be greater, for sure. All right, now what made this so hard? Is it the late hour or something else? The whole thing with this, knowing what it really means to take a root. It means find two numbers, or a number. Find one number where you multiply it by its. Okay. What made this problem hard, guys? What made this hard? Illuminate just swiped my mic for a moment. But I got it back. Smile if you can hear me. What made this hard? What made this problem hard? All right. Maybe we should poll. Answer A if it was not knowing root rules. Okay. B if it was the late hour of the night, and C if it was something else. All right. Okay. All right, so most people are saying root rules. Okay, so root and exponent rules. I think that's our big takeaway. You have to know this stuff for the GRE. It's not very hard. You knew it in middle school. You need to review, though. Okay, you need to do some brush up and do some of these problems. These are not the kind of problems that you want to miss because they're not that much work to get right if you reviewed those rules. Okay, now I'd like to try a different type of problem. I'd like to move on. I'd like to try this positive-negative problem. Again, I'm going to set chat to moderator, and I want you to send me your answer. Check this problem out. All right, so I have a bunch of people answering, which is good. Which of the following must be true? Okay, but we have a lot of wrong answers. If A minus B is greater than A plus B, okay, and then I have questions about A, B, and A times B. All right, I know that A and B are integers. Okay, so when I see an expression like this, I could immediately jump to plugging numbers. But what would a wiser strategy be when I see this expression, rather than immediately plugging and testing numbers? It says must be true. Okay, so one strategy would be to say, well, could I make it work when, you know, A is negative? Okay, what should I do, anybody? What could you do? Let me turn chat back to public. Anyone have any ideas? You see this statement, all right, and there's a big hint in the form of the statement. Is this in simplest form? Anybody? Is this in simplest form? anytime the GRE gives you an expression that is not in simplest form, the test writers are trying to hide something. Okay? How could you put it into simplest form? Anybody see anything here that looks suspicious? How do we simplify this? All right, Hannah's typing. Excellent. Excellent. I know it's not, yeah, add -a to both sides. Exactly. Okay. Now, I'm allowed to add and subtract variables. I'm not allowed to multiply by variables across an inequality because I don't know whether they're positive or negative. But I can add and subtract. That is allowed. Okay, so then I get -b is greater than b. What does this tell me? What has to be true if -b is greater than b? There's one more mathematical step that we could take, but what has to be true if -b is greater than b? B has got to be negative. Exactly, Adam. And if you think about it, you know, if I add b to both sides, all right, which I could do, okay, then I'm saying that 0 is greater than 2b. All right, well, I divide both sides by 2. I can do that. It's a positive constant. And it's just saying 0 is greater than b. So b must be negative. All right, so 2 has to be true. 1 does not have to be true, right? The sign of A doesn't matter. Okay, and nobody thought that 1 was true. But 3 also does not have to be true. Why not? I know that b is negative. Why don't I then know that A times b is negative? Why not? What's the flaw in my reasoning if I think that A times b is negative? What's the error that I got tripped up with? All right. Type, come on. Anybody see this? What's the problem? What's the case I have to think about? Why doesn't it have to be that AB is less than 0? I know B is negative. What's the issue? Oh, good. Lauren is typing. Yeah, exactly. Okay. If A and B are both negative, I'd have negative times negative, which is positive. So this does not have to be true. All right. All I know from my original expression is that B must be negative. A is just added on. It's sort of a distractor. If I know that B is negative, A times B could still be greater than 0 as long as A is also negative. All right, and again, it's a must be true. This whole thing with the mathematical logic thinking. Okay, what does it mean? All right, what does the language mean? Questions? Smile if you're comfortable with this one. Otherwise, put up that frowny face. All right. Okay, everybody oxygenate for a moment. We're not going to do too many more of these. I do want to show you one other thing that you might see. These are medium, Adam. These are not particularly hard. These are medium. Okay, this particular one. There are harder ones of these, but this one is a medium one. Okay. Jump up and touch the ceiling. I love Stacy's suggestion. Oxygenate. The tip-off here is that the expression is not in simplest form. This is just, you know, a beacon. GRE test writer, you know, trying to do something tricky. Oh, just simplify it and you'll see something. All right. I want to take a look at a similar type of problem. Let's go and let me flip through to it. Okay. Let's try this. All right, and then we'll declare victory, but I really want to try this one. All right, oh no, I only have 3 answers up. The vast majority of people have answered, yikes. Ah, good, more answers. Okay, This is great. Okay, so we have a winner here. The preference is for C, and nobody picked A, which is really good. All right, how did we do it? How did you do it? Smile if you did it by testing numbers, and hand clap if you did it by thinking about what has to be true. All right. Okay, good. Both techniques work. All right. You can quickly figure out A times B. A is even, B is odd, A times even. Which of the following cannot be even? Well, A times B is always even, so that's, you know, think about 2 times 3. Easy, right? Okay. And then sometimes these fool people, but they didn't. And again, you could just say, oh, 2 to the 3. Oh, that's 8. It's an even number. All right. And really, you know, if I have A to any power, any integer power, and A is even, 2 to the, you know, say this is 6 plus 1. Yeah, that's even as well. So the only ones that could be puzzling are these two. Okay. So the thing is, though, you can't tell with 2 and 3. All right. So if I've got odd over an even, odd over even, okay, you know, 3 over 2, not an int, but even over odd here, you know, 2 over 3, not an int. But why is the answer C and not B? It's not B, okay. Why is the answer C and not B, guys? Somebody who got C, why does it have to be C? Even though when I tested 2 and 3, it looked like either would be fine. An odd divided by an even can never be an integer. Thank you, Adam. And our example for B, if you just think about it, you could divide 6 by 3, okay, and get an even. All right. All right, and really what you're setting up, if you did it theoretically, you would want to say, is this possible? Is even over odd ever equal to an even? And it would be sure, because an even could be an even times an odd. All right, and that's how you would rule out B. All right, great job. Great job. But we need to do some review. Okay, really good job at figuring it out after the fact. I want everyone to try some of these problems, all right, because you can become pretty fast at them. They're just these clever little puzzle tricks, but they're not all that hard to do, okay? We're going to take a look now at data interpretation. We don't have a ton of time, but I just really want to show you some graphs and some techniques. There are not a lot of these questions on the GRE, but it's helpful to have a good approach to them. Now, how many of you work with, say, charts in Excel? How many of you are familiar with graphs and charts for presenting data? Just information presented in graphs and charts? Okay, a couple people. All right, it really helps to look at graphs and charts and to be able to read them. Sometimes people tell me that half the challenge is just reading the charts on the GRE. All right. Now, the charts that they use are just sort of standard charts that you would see in Excel: line graphs, bar graphs, pie charts, and tables. A really important thing is to use your calculator intelligently. Sometimes people start punching buttons hoping for magic to happen. That's not really a good idea. You want to think, okay, what numbers do I need to multiply or divide or do something with, and figure out, you know, what the expression should be before you punch anything into your calculator. All right, that's going to be one of our themes that we'll see. Okay, so just in terms of the theme of reading the graph, all right, just looking at this problem, first of all, okay, how many oranges were shipped in 1985? Just type it into chat, just so I know everyone is able to read this kind of chart. How many oranges were shipped in 1985? How many crates of oranges? Here, I'll turn chat private if anyone's uncomfortable, but just take a look. Take a look at the graph. All right, how many crates of oranges shipped in 1985? Okay, so the way you read this chart, all right, the answer is 2,500 for 1985. You go to the 1985 part of the graph, all right. This is what's called a stacked bar graph. And you say, okay, so oranges are just this section, up from about 3,500 here to 6,000. That's 2,500. And the way I do it that makes it easier, I think, oh, each one of these bars is 1,000. So that's 1,000, 2,000, and then half a bar. So this is 2,500. All right. And then the number of apples here, that's the easy one to read. The apples, all right, this is oranges. The apples here would be 3,500. And some people gave me the answer for the total number of fruit, total amount of fruit, total number of crates. That's what the 6,000 is. Okay? So now that you can read the chart, if you look at the problem, why don't you guys pull in an answer? Just take 15, 20 seconds. We've now figured out how to read the chart. All right. Okay, so seeing the answers come in. All right, and again, this is approximating. We thought that there were about 2,500. Actually, it's a little less than that. You know, if I look at this, it's not quite at the middle. Okay, but if I go to 1983, this looks like 2,000 crates of oranges. Okay, and so I'm really just looking for the thing that's closest, and it looks like it's got to be B. You know, 100 is way too small, 700 is way too big. And as I look at this again, I think, well, it could be 2,400 here. You know, the light gray isn't quite halfway down. Okay, and I get to B. All right, good. Okay, so let's look at another one. Again, just reading these charts is so important. Now this is a question about the percent increase in the number of crates of oranges shipped from 1980 to 1983. What's the formula for percent increase? How do we calculate percent increase? Anybody remember? What's our percent increase formula? What's percent increase? Okay, so if I look at this, I mean, first I have to be able to read the values. And it looks like, okay, so it looks like about 1,500 oranges in 1980, 1,500 crates. 1983, it looks like 2,000 crates. So how do I figure this out? What's my formula for percent increase? Anybody remember? Yeah, it's the change over the original. Exactly. Exactly, Adam. Thank you. All right, now they do expect you to know this, the percent increase and the percent decrease formula. Okay, and it's not too bad. I mean, it's just the change over the original. Okay, and then you would just calculate it with your calculator. All right. So our change here, it increased by about 500, right? And our original was 1,500, okay? So if I look at that, it's about 33%. Now notice that they are tricky. 25% is also an answer, and that's in case you put down 500 over 2,000, okay? But we're looking at the change from 1980 to 1983. All right? Smile at me if you remember this formula. This formula is very important, all right, for these DI problems. All right. If you don't, I'm going to say, you know, just review it. It's not that tough. Put it on a flashcard, okay? And look at it, and you just think, oh, it's the change. Well, how much did the value change over the original? That's the percent increase. Percent decrease is the same thing. It's the change over the original. All right, let's take a look at another chart. Okay. Another chart problem. Okay, so pie charts. Now pie charts are cool. They're used to show percentages. Okay. Typically when the GRE gives you a pie chart, they'll tell you the grand total. All right, not 100% of the time, but I would say more than 90% of the time. Okay. So if you have a question like this, approximately how many more Nissan Brigadoons are owned than Chevy Diphthongs? All right. Chevy Diphthong, Nissan Brigadoon. How would I figure this out? There are two ways. There's the laborious, time-intensive way, and there's a fast way. How might I figure this out, though? Either way will do initially. How could I figure this out? Anyone? You can put up an answer if you see it. But how would you figure this out? All right, if you're tired, hang in there. I know, we're almost done. Okay? But it's important to refresh this stuff, how to look at graphs, how to understand graphs. All right, what would you do, even if you don't have your calculator out? Okay? And I love Stacy's question. Okay. All right. It's a lot easier if you look at this problem and you subtract the percents first. Okay? And this works perfectly well. The reason it works is that you're saying, okay, so I've got 0.29, that's the number of Brigadoons, times, all right, 806,448 minus 0.17 times 806,448. And I just factor out that 806,448. Now what I saw when I took the GRE, they actually didn't even make you go this far. They'd ask you to pick the formula, which was the correct mathematical expression. Okay? They would actually just ask for the mathematical expression. So you didn't even need to calculate it, but you do need to know that this works mathematically. All right, and then the answer they gave you was 0.12 times 806,448. All right, but this is why you can just subtract the percents first. Okay, so now, quick question. If I were thinking, and what Stacy's talking about, taking benchmarks, this is really helpful too. It avoids having to press the buttons on your calculator. Okay, very, very helpful. I'm going to ask you, how many more Ford Moots? How many more Ford Moots than Chrysler Picantes? How many more Ford Moots? Quickly, quickly, without a calculator. How many more Ford Moots than Chrysler Picantes? Here, I'll set it to private messaging. How many more Ford Moots than Chrysler Picantes? Here's the Moot. All right, and here's the Picante. All right. Okay, so 20% isn't the answer. That is 26% minus 6% on the same graph, but what is the answer approximately without a calculator? Yeah, now I've got a lot of people answering, 160,000. Okay, good, because it's 20% of this 806. All right, 10% would be 80,000, so you multiply that by 2, you get 160, and 162 is fine as well. Okay, so you just want to be able to do this sort of stuff quickly so these problems don't waste your time. You have to understand how to calculate this stuff. All right, so let's look at another one. Okay, sort of similar. This time I'm going to put it on a timer. All right, we want to calculate this ratio. How would you do it? Here we go. Here's a 2-minute timer. All right, good. It looks like most people got that. And again, what you do, okay, we want the ratio of Picantes, Chrysler Picantes to Nissan Brigadoons. I know. Who came up with these names? They crack me up. But it must be the time of night. Okay, so Chrysler Picantes, well, that's 6% of our, 806,448. But before I do the math, all right, it's over 29% of the same number. So I can really just divide the percents. I can really just look at the percents for the ratio because that 806 number, the hard part, will cancel out. Okay, so then I really have 6 to 29. What is 6 to 29 the closest to? All right, well, it's about equal to 6 over 30. Right, it's about 6 over 30. Remember those squiggly equal signs from high school? Anybody remember this thing with the squiggly equals? Smile if you remember the squiggly equals. All right, a couple of people remember the squiggly equals, the about equal to. Okay, it's really useful on the GRE. 6 over 30, all right, that is exactly 1/5. Okay, so the ratio, the answer is B. Okay. All right, so that wasn't too bad for people. All right. Okay. Oh, you had that at first and then you second guessed yourself. Yeah, okay. So one way to avoid second guessing, write out the steps rather than doing it completely intuitively. You'll feel more confident because sometimes we do see this intuitively very quickly. But something about writing out, just we know, then you know, and you don't have to worry. All right, let's do one more of these, and then I want to just show you one more fun problem with medians. Okay, let's try this, sort of the same problem only inverted. All right, I know it's late, but great job for hanging in there. Look at this. Everybody who answered got it. Okay, so which type of car do citizens of Townsburg own approximately 100,000 of? How do we set up the math for this? There's a formal way and there's an intuitive way. All right. How would we set up the math? What is really interesting about this number, 100,000? You know, I look at this and we've got about 800,000 total cars. What am I really looking for? What am I looking for? All right. What am I looking for? Now I could say that X over 100,000. Okay. I could try to set it up as some kind of a fraction. Yeah, I like what Adam is saying, though. I think this is the fastest way to do it. Because I'm looking for, I want something, what about 1/8 of the cars? And Adam actually was the first answerer, so this was very nice. What about 1/8 of total? Okay, so there's some things that cannot possibly be the answer. 29% is way more than an 8. 17% is way more. 2% is way less. 26% is way more. 8% has to be less than an 8. Okay? And so does 6%. And I can just check it. You know, I think if I think 12% might be an 8, I would just multiply 12 by 8. Okay? And then get 96. All right? You do have to be able to figure out what an 8 is. Okay? I love what Stacy did. Yeah, just figure out what a quarter is and take half of that. A quarter is 25%, so it's got to be this. It's got to be about 12%. Very nice way to do it. Okay? You don't actually have to do the formal math, as long as your logic is good. All right, questions about that one? I want to do just one more. First of all, do you guys know what the median is? What is the median of a set? Type it in. What's the median? Definition of the median. Doesn't need to be a formal definition. but just what is a median? It's an important number in statistics. The middle number, exactly. Okay, the number that splits. All right, so a lot of times they're going to ask you to find the median. Okay, and I'm going to put up one of these median problems. And let's just make sure we're all comfortable with how to solve them. All right, and then we'll just do a quick review afterwards. Try this one, our last problem of the evening, I promise. Okay, now a bunch of people didn't answer, all right? Now they're trying to trick you into just picking 1991's value, okay? But when we calculate the median, we need to line the numbers up in order and pick the one that splits or the one that's in the middle. First thing we need to do that is figure out how many numbers. How many points are there on this graph? Anybody? Type it into chat. How many numbers are we talking about? Yeah, Lauren's got it. It's 19. Okay, and the way I do that, I say, okay, so it's last minus first, and then you add 1. Okay, so 2000 minus 1982, that's 18 plus 1 equals 19. So the number I'm looking for the number that would split that. So I'm looking for the 10th number. Now, I have this little trick that I use on the GRE when I have a problem like this. Okay, and let me just set it up correctly. I use my finger to count up. All right, so this is my finger. Okay, and I want to find the 10th number. All right, so just starting, that's 1, that's 2. All right, I touch the screen. Yeah, what are they going to do to you? 3, 4, and then there's the 5th one, the 6th one, you know, the 7th, the 8th, the 9th, and the next one's the 10th. Aha, there it is. I found my answer. And it is B. Okay, done with the finger. All right, rather than writing down all these points and figuring out, you know, putting them in order, that's just way too much work. The finger is much faster. Okay, I know one GMAT instructor who uses the piece of note paper. I need to be writing on that piece of paper. I find the finger is easier. All right, but play with it. This goes under the category of, well, you have to be able to read those graphs. All right, questions. Many people did not answer. Smile if you understand now. Okay, if you see what we're doing, you have to know the definition of median. Blue face if you don't. All right, and then you sometimes just need a practical technique for getting to the middle of the graph. Much, much easier than rewriting the numbers to put them in order. All right, good job. Okay, Stacy has a tip. Don't take the test unless I know it's very late for some of you. Thank you so much for hanging in there with us. We are all done. Good job. Come to our class next week. We still have content to go. All right. It's 5 a.m. in Cairo. Oh my goodness. It is very, very early or very, very late, Hannah, depending on your schedule. Okay. Hang in there with us. That is really real devotion. I agree with Lauren. That is impressive. Yes, let's all clap for Hannah. That is impressive devotion to GRE class. Wow. Okay. All right, so we are done, but I am so happy to answer anyone's questions. Any questions? I know it's late. I know brains are going. Or it's very early if you're Hannah. Brains are definitely gone. All right, so on the practice test, these seem to come up at the end of the section. Adam, yeah, a little more often at the end of the section. I've noticed that as well. They typically warm you up with the straight out numerical problems. All right, I think this is sort of the math equivalent of reading comprehension because you really do have to extract the data from the graph. Okay, but there is no rule that it has to be less, but they do seem to come later in the section. All right, or there's no rule that I'm aware of, nothing that they've published or said publicly. Okay, anyone else? Any other questions? If not, I'm just going to turn off the tape. You guys have our email addresses. You can send questions. Definitely do the math reading for our 9th class. We're going to do math first. I'm thinking that the late hour may have made math harder than it had to be. Okay, we're making fantastic progress, and I am looking forward to a great last class. Yes. Definitely do the reading for math. Even if you don't do it all, you don't have to be a perfectionist, but you'll get a lot of benefit out of at least skimming through it and focusing in on the stuff that you've definitely forgotten. Okay, off with the tape.